In my earlier videos, I talked about direct variation, inverse variation, and joint variation. Combined variation is very similar to joint variation, where you have more than one independent variable that's related to your dependent variable. Let's do a warm-up question. If y varies directly as x and inversely as the square of z, and y equals 20 and x equals 5 and z equals 3, find y when x equals 10 and z equals 20. The first thing we want to do is to write our given information in an equation form. So we have y varies directly, so y equals, that's our constant of proportionality, which is k, and it varies directly with x, so we can say it's kx, and inversely, so it's over the square of z. Now that we've written down our equation, we can plug in our numbers. So we're going to take the next set of information here, so y equals 20 equals, we don't know what our k is, x equals 5, and z equals 3, and don't forget the square. 3 times 3 is 9, so I'm going to multiply both sides by 9 to get rid of my 3 squared. To cancel out, 9 times 20 gives me 180, and I'm left with that being equal to 5k. Divide both sides by 5, and that leaves us with k equals 36. So we can plug our k equals 36 into our original equation. So y equals 36x over z squared. And then we want to find our y when x equals 10 and our z equals 20. So I'm going to change my x to 10 and my z to 20. Simplify. 36 times 10 gives me 360, and 20 squared gives me 400. We can cancel out the zeros. 36 and 40 are both divisible by 4. So that leaves me 36 divided by 4 is 9. And 40 divided by 4 is 10. And that's how we solve this problem. Here's another problem. I've changed it up a little bit and changed some of the numbers to fractions. So if y varies directly as x and inversely as the square root of z, and y equals half when x equals 1/5 and z equals 1/9, find y when x equals 10 and z is 100. Again, let's turn our word problem into an equation. So y varies directly, so we can say that y equals k, constant of proportionality, varies directly with x, so it's kx, and inversely with the square root of z. Let's plug in our given values. We're told that y equals half, and we're trying to find our k. We don't know what our k is. We're told our x 1/5 and our z is 1/9. Freeze when you see the fractions. Let's keep going. Simplify your square root. 1/9. Square root of 1/9 is 1/3, because the square root of 9 is 3. Half equals 5k divided by 1/3. And when we have a fraction divide by another fraction, we can change that divide to a multiply and flip our fraction behind the multiply sign to take its reciprocal. Simplify by multiplying across. K times 3 gives me 3k. 5 times 1 gives me 5. And we can cross multiply as so. 5 times 1 gives me 5 equals 2 times 3 gives me 6k. We want to find k, so we're going to divide both sides by 6, and that gives me k equals 5/6. Then we can plug our k equals 5/6 into our original equation that we set up, so we can say that y equals 5/6x over root z. Now we want to find out y when x equals 10 and z equals 100. My x to be 10 and my z to be 100. I can put my over 6 in the numerator to the denominator. Square root of 100 is 10. So in this case, the 10s actually cancel each other out, and I'm left with y equals 5/6 when x equals 10 and z equals 100. Now this is a rare instance, and I just made the numbers up, so it just happened that our y, when you were given those values, happened to be the same value as your k. It's not going to be the case in many other instances. Here's an actual word problem. The volume of gas varies directly as the temperature and inversely as the pressure. If the volume is 250 cubic centimeters when the temperature is 400 kelvins and the pressure is 20 pounds per centimeter square, what is the volume when the temperature is 250 degree Kelvin and the pressure is 35 pounds per square centimeter? So let's define all our variables. We're going to let V equals volume, T equals temperature, and P equals pressure. Then we're going to turn our word problem into an equation. So we have volume V equals, it varies directly, so it's K of T over P because it's inversely proportional to the pressure. So in almost all cases, what we're going to find is our K first before we find our final solution. And in order to do that, we're going to plug all our given variables to find K. So here we're told that volume is 250, K is unknown, and that's what we want to find. T is 400, and P is 20. Cancel out our zeros. 40 divided by 2 is 20. 250, 20K. Divide both sides by 20. Zeros cancel out. The 20s cancel out. 25 divided by 2 equals 12.5. Now that we have our value of K equals 12.5, we can plug it back in our equation. And we can say V equals 12.5 T over P. Now we want to find the volume when we're given new values of T and P. And our new T is 250. Our new P is 35. The answer doesn't result in a nice whole number or a decimal number. So I've rounded it to 2 decimal places, which results to 89.29 centimeter cube, which is the units for the volume that was given in the problem. The question itself did not tell us to how many decimal places we need to round to, so we just round to 2 decimal places if we're not told anything. So your volume is 89.29 centimeter cube. This problem is a little bit more complicated, but the method's still the same. A cylindrical column with a circular cross-section can hold a maximum load that varies directly as the fourth power of the diameter and inversely as the square of the height. A 5-meter column with a 1-meter radius will support 60 metric tons. How many metric tons can be supported by a column 10 meters high and 5 meters in diameter? So we always state what our variables are. In this case, we're talking about load, diameter, and height. So we're going to let L equals load, D equals diameter, and height equals H. Now we have to be very, very careful in this problem because if you notice, we were not given the diameter, but we were given the radius. Bear that in mind when we work out our numbers. So we're told that L varies directly, so it's K D to the 4th power, and inversely, so over H squared. In this first part of the problem, that our load is 60 metric tons, so L is 60, K is unknown. Now we're not told what our D is, we're told what our R is. R is 1, so my D is 2, because the diameter is twice the radius, over H, which is 5 squared. So we simplify that. 2 to the power of 4 is 16. And 5 squared is 25. And to get rid of my 16 over 25, we're going to multiply both sides by the reciprocal of 16 over 25, which is 25 over 16 on both sides of our equation. 60 and 16 are divisible by 4. These cancel out on the right-hand side. And that simplifies to K equals 93.75. Then we can plug our K equals 93.75 back into our original equation. And we want to find L in our final problem. So we're going to say L equals 93.75 times our new D, which is 5, H, which is 10 squared. And when we simplify that, we get our load is 585.94 metric tons, rounded to 2 decimal places. Even though they didn't tell us how many decimal places we rounded to, we're going to do it to 2 decimal places. If you like this video, please be sure to like and subscribe to my channel. Hit the bell button for notifications. I offer notes, lessons, worksheets with full answer keys for sale, as well as online tutoring. Links down below. If you'd like to support me via Patreon, I have a Patreon account. Links below. Thank you for joining me, and I hope you found this session helpful.